All right. Hello, everyone, and welcome to today's Fusion Friday. My name is Alex Alvarez, application engineer here at KETIV Technologies. For today, we are going to be talking about Fusion 360. Now, in specific, we're going to be talking about the CAM workflows inside of Fusion. Again, CAM is one of the primary tools that a lot of people tend to gravitate towards inside of Fusion. Not only that, it's also seen as a platform. So again, if you're doing any design work, any engineering work, you can carry all of those tasks and then get ready to manufacture your part all using the same tool. Again, so CAM is a pretty big topic that often gets requested. So we're going to go through a workflow, again, walking you through your setup, how do you add Toolpaths to it, and then how do you post out to your machine. So let's go ahead and jump right in. Again, I like to keep it short, so not a huge fan of PowerPoint, so I'm just going to go ahead and jump right into the software. Again, if you guys have any questions at all, feel free to use the chat box. It's a little bit different from some of the previous Zoom sessions that we've been using. So again, if you guys need help with that, let us know. But again, feel free to just ask questions or just ask anything that really comes to mind. So again, if this is your first time inside of Fusion 360, this is essentially what you're going to get, right? So again, you have your basic design tools, you have your sketching tools. Again, if you're going to do any surface modeling, any sheet metal work, it can all be done inside of the software. Now, what I was mentioning earlier is once you're done with your design work or your assemblies, you can right click or click on the little drop down here, and you have different environments that you can navigate to. Right. So again, if you're going to do any sort of rendering work for marketing, any sort of simulation, make sure that your proof of concept is actually going to withstand once you release the product. This is where you would take care of some of the simulations. Now, not only that, again, Fusion 360 is going to be a cloud-based tool. A lot of people don't really understand really what that entails or what that means. Essentially, Fusion 360 is going to be connected to a cloud server. What that means for you is that really you can just start sharing your projects, start sharing designs much more effortlessly. Right? It's going to be a seamless workflow when it comes to sharing your designs. As long as the other person has Fusion 360, really they're going to have access to your designs no matter what. So you can go ahead and invite them. Notice that we have a couple people that are already invited to this project. Again, they're going to have access to it. They can view the project. They can modify parts if they want to. Again, they're not going to overwrite your work necessarily because you are working with versions here. Again, there's a whole new topic webinar that kind of goes over how to work with versions. But again, if you're using Fusion 360 and maybe you need a little bit of help on sharing projects or maybe understanding what the best workflow is for that, again, just let us know, give us a call, and we'll help you walk you through that. So again, let's go ahead and dive right in. This part it might seem a little bit familiar. It's actually a CAM samples part. Again, there's tons of help inside of the CAM samples. You guys can always just go in here. Everyone has access to them. If you scroll down, you go to the CAM samples, you guys can see that there's a few different parts that are already programmed. Now, nice thing about this is that you can just open up a part and investigate it, see what kind of settings the Autodesk people have used to create some of these toolpaths, right? So maybe if you want to learn a little bit more on the 3D milling side, open up this part and take a look at the different strategies that were used to create some of those 3D milling toolpaths. Now, for today, we're going to be talking about fourth axis toolpaths. So there's actually been a decent amount of work done in the past couple months in terms of what kind of functionality has been built into Fusion. So for today's webinar, we are going to be discussing some of those new functionalities. Again, throughout the next couple months, we're hoping to actually start talking or investing a little bit more time on the what's new in Fusion. So again, showing you workflows, showing you how to best use some of these new functionalities. So if that's something you guys are interested in, again, make sure that you guys stay tuned for these next upcoming months. So for this one, again, let's say that we're done with the assembly, we're happy with it. Again, this is, if you guys aren't familiar with the Haas Rotary, it's going to be essentially just a rotary vise that if you have a fourth axis capabilities, it's going to rotate around the x-axis, right? So one thing that a lot of people still get a little confused on is they think that this is going to have machine simulation. This is really just for my benefit. It's just for me to visualize how the part is going to be fixed. It's also used as a template. So if I have just this portion as a template, what I can do is I can just swap parts in and out. And again, this is going to allow me to quickly start programming these parts and then get them out the door much quicker. So this template actually has a couple of things. So not only does it have the machine table, not only does it have the rotary, but there's actually a work point that I created. And again, this is a self-centering vise. So I created a work point on the center of that vise, and it's going to be used as my work corner system. So again, now don't need to worry about programming that WCS or trying to figure out where the best optimal WCS is going to be for this part. It's always going to be the same no matter what. Right, so that's, again, just one of the benefits of creating templates inside of Fusion here. So let's go ahead and jump right into the workflow. Once you're done with the design, like I said, hit the drop down, work your way down to the manufacturer tab, and we are now inside of the manufacturing environment. Now, again, a couple changes have been taking place inside of the manufacturing environment. One of the biggest ones is that there's actually manufacturing extensions now available. A lot of questions around manufacturing extensions. Again, we have a webinar, I think it was last month, that covers some of these extensions and some of the best ways to really start programming or taking advantage of this new functionality. If you take a look here, so I already have the manufacturer extension purchased, but if you take a look at the generative design option, so there is an option to use a trial, and I probably should have waited for this one, but you can also do day-by-day purchases. So if you just need to use the manufacturing extensions for a specific day, just use a day pass and you guys are gonna have access to it for that specific day, right? So before it was just monthly. Now, not only do you have the day-by-day access, but if you guys want to see what it's about, there's also a trial version available for you guys to try. So pretty neat. Again, this little drop-down tells you exactly what comes included with the manufacturing extension. So you have additive manufacturing, 5-axis collision avoidance, hole recognition, right? So you guys can kind of take a look at this. So pretty neat stuff. And again, this is paid because there's a low price point right now for Fusion 360. And this is some advanced functionality. So obviously Autodesk has to charge a little bit of money just to make ends meet there. So I'm going to close this out. What I want to point out is that for this specific workflow, you actually don't need any of the advanced manufacturing extensions here. You can actually get by using just some of the traditional toolpaths that you see here. But again, we'll kind of walk through that as we're programming this part. So first things first, again, just kind of walking through the workflow. If this is your first time seeing Fusion 360 or seeing someone program inside of the software, really the workflow is going to be very linear. And I always like to point this out because usually a lot of CAM softwares, they're all over the place, right? So you have to change tabs, you have to switch, between a specific add-in. Maybe there's some additional functionality that maybe you don't have enabled, or there's a separate module for a 4th-axis rotary toolpath that you have to activate. That's not the case here, right? So really all you need to worry about is what are you going to be doing? Is it going to be milling, turning, additive? Once you know that, the workflow is going to be consistent throughout the whole programming experience, right? So it's going to be a very linear workflow, like I said, starting over here with the left, with your setup, adding toolpaths. If you're using 4th or 5th axis machines, you have multi-axis toolpaths. Again, this is a part of the manufacturing extension. So modifying toolpaths, you can trim toolpaths if you like. If you want to see in-process stock generation, so I'll talk a little bit about this towards the middle of the presentation. Simulate, and then this is kind of the end goal, right, is posting out to your machine. So this is going to be the finish line for us. Now, like I said, if you're new to the software and maybe you're not familiar with some of the terminology, just hover your mouse over a command and it tells you exactly what that command is going to be doing. And it gives you actually a pretty good representation or a picture of the some of the settings as well. All right, so pretty neat. I think the user interface is pretty straightforward. So let's go ahead and start off with the setup. It's going to be the biggest part here. Now you want to make sure that the setup is correct, otherwise your entire foundation is going to be incorrect. right? So first things first, again, inside of this dialog box, if you guys are using machine configurations, which we haven't really talked about too much in any of our webinars, but that's something that we can definitely talk about. You can go ahead and select your machine. For me, I don't have a machine set up, so I'm going to leave that blank. It's going to be a milling workflow. I typically like to set this after I select my model, right? So the model is going to be what you're actually going to be programming. So for us, it's going to be this model here. Notice that you have manufacturing model. Now, this is actually something that's been recently introduced. Reason why they introduced this is because if you have a design model or an engineering model and you're going to want to make changes to it. So usually if you're going to manufacture something, sometimes you might want to just leave a little bit of stock, add some holes so you can clamp the part down, or maybe you need to, just make some small changes for manufacturing purposes only, right? So these are features that are down the road going to get machined. You don't want to make those changes to the engineering model. This is where the manufacturing model comes into play, right? So again, you're just affecting the manufacturing model at this point. You're no longer changing the engineering model. So like I said, this is some new functionality. This I can definitely see a lot of, a lot of helpful reasons for people to use the manufacturing model. So we are going to be doing a topic here in the near future discussing this. So we selected the model. We have our WCS here. Now, again, you want to make sure that you orient your WCS correctly. Otherwise, everything is going to be incorrect down the line. So like I was mentioning, you have, or we have a stock point here, and I don't think it's visible at the moment. But if I expand my models, and again, this is what holds all of your information, your part information. Notice that I'm working with the 4X demo part. I have a few sketches here that I can modify. Right. So again, if the sketch was inside of the 4X demo, this is where you would find the sketch. For us, it's going to be inside of the Haas Rotary table. So I'm just going to extend this. And it might just be easier if we do it in the design environment here. So find where that's at. There it is. And then turn the sketch on. Right, so a little hard to see, but we'll go ahead and we'll hide the part here in just a second, just so that we can select it easier. So again, going back to the setup, selecting our model, orienting our part. Now, what I like to do when I orient the part, again, a lot of people like to use features on the model. That's completely fine. You want to be cautious though, because if for whatever reason that feature gets deleted, gets suppressed, gets changed, your orientation is going to change. So instead of using a feature on the model, what I like to do is just use the origin axis, right? Those are never going to change. You can never delete them, and you can never modify them, right? So the Z axis is going to be pointing up and down. Now, this is what gets a lot of people, right? Especially if they're brand new to manufacturing or just CNC machines in general. You have to make sure that your x-axis is pointing correctly. Right? Not only that, so this is going to be an a-axis machine that rotates around the x-axis. So therefore, my x-axis is going to be aligned in this fashion here. Right? If it was if it had a b-axis or maybe a c-axis, again, you would want to make sure that you orient your model correctly. Otherwise, the G code is not going to be correct when you post out to your machine. So a little hard to see, but you can kind of see the point there in the center of the vise. So that's going to be my next option, selecting my stock box point. Right, so for me, notice that if I try to select that, it doesn't allow me. Right, it's only giving me points around the stock. Just make sure that you set the drop down to be selected point. Right, we'll set this. This as our point. So that's really the first portion of creating your setup, right? The second portion is just specifying what kind of material we're going to cut. For us, it's going to be a fixed size cylinder. Now, this was an issue a couple months ago. I'm not sure exactly when they added this functionality, but now you have the option to select the axis for the fixed size cylinder. right? If you had a milling operation type, it was pretty difficult to orient your cylinder correctly. For the most part, you really had to create a cylinder body. For now, you actually have the ability to specify what the axis is going to be for your cylinder. Right, so we can set this to be 3.5. And this is something that to be completely honest with you, I have to follow up on, and I have to see. So typically, and I don't think it's because of my, well, we can try it out actually. There it is. Okay. Yeah, so you want to be careful there. Again, typically if you're working from left to right, obviously that's going to be 0, right? But our orientation is going to be flipped, right? Because if we're looking at the machine in this fashion, really the front is going to be this side, and then the back is going to be the back of that cylinder, right? So instead of offset from front, change that to be offset from back. And we can do 50 thousandths. And then something that we can just clean this off with, right? And that's really going to be it for our setup. So again, if you ever need to come back into the setup, make changes to it, modify it, you can always just go back to this folder, right click, and then edit the setup. Now for this one, I'm just gonna go ahead and give it a name, right? So initial setup, and there it is. So again, x-axis, really the biggest part is probably going to be making sure that the x-axis is oriented correctly here. Now, a couple assumptions. Obviously, if you have turning capabilities, you want to make sure that you turn the part first, and then you do all of the milling functionality in it. Again, what I'm going to assume is that we don't have any turning capabilities. We just have 4th axis machines. We have milling machines, no turning capabilities. So let's see how we would do our best to really machine some of these features using a 4th axis rotary table. So the first thing that I would probably want to do is probably take care of this portion here, right? So mill down to that cylinder. A couple ways to do it. Really, the best way that comes to mind is using a rotary style toolpath. Now you can use the flow toolpath, and I'll show that here in just a second. But what I'm going to take advantage of is just using the new rotary toolpath. Now, again, this is a part of the manufacturing extension. So if you don't have that, you aren't going to see this option. So use the rotary tool, just selecting our tool. Again, that workflow is always going to be similar. You're always going to see those tabs no matter what. Right, so you're always going to see the tool, geometry, radii, which really is referring to the heights, passes, and then the linking tab here. So I'm going to go ahead and select my geometry. Notice that the axis is set incorrectly right now. We're just going to go ahead and use the setup x-axis. For this one, we're going to say selection, and we're just going to focus on that area there. Right, and that's all I'm going to change. Again, if I'm brand new to this toolpath, I want to see what it does first with just a few modifications. Right, I don't want to bog down the toolpath with different options if I'm not sure how it's going to work. So you can see what it's doing, and obviously it's doing what we should be expecting, right? So it's doing a rotary style toolpath, and it's trying to machine all these little pockets, right? So like I said, there's a couple ways to do it. You can set the height or the radii to be this diameter, right? That's an option. You can try that out. So let's see this. And this is actually not the method that I had in mind, but let's see if that works. By the way, so I came into the office thinking that it was going to be a little bit quieter, but it turns out that they're doing construction here. So if you guys hear some banging noises, I apologize. We'll do our best here to kind of muffle them out. But you can see that doesn't really work, right? So again, we gave it a try. That really didn't work. So the next option that I can think of is just creating a reference surface, right? And that's one of the topics that we're going to talk about is how do we manipulate some of these toolpaths, not only using the settings, but also using some of the functionality that's built into the software. So let's go into the design tab. And again, you can, if this is something that you're going to do quick and dirty, you can leave it active, right? So you can leave the main assembly active. What I like to do is just do things correctly. So let's activate first the part, which is going to be this 4X demo. And now any change that I make or any additional features that I'm adding to it, it's all going to be inside of this 4X demo part. All right, so I'm going to go into the Surface tab. I'm going to go ahead and create an offset. A couple ways to do it. So you can either create an offset here, patch this up, but that's a little bit too much work. So what I would do is just take advantage of some of the geometry that's already there and just use this surface here, right? So for now, what I'm going to do is just hide the visibility of the solid body, right? So hide this visibility. And now what I can do is I can come in here, extend this out, and set that to be perpendicular, right? And now I have the option to create this just nice, clean, cylindrical surface. Now I'm going to turn this on just for measurement purposes and measure from this face to this front face. It's going to be minus 1.5. And what I'm going to do here is actually keep in mind what tool I'm going to be using. So I'm going to be using a 3/8 inch tool, right? And so I'm going to divide that by 2 because I want the center of that to be on that edge, right? So I'm going to say okay to that. I'm going to hide this body one more time just so we can see what we got. I don't need this surface anymore, so I can delete that one. And I'm going to do one more change here and extend that edge a 1/4 inch, right? So just a little bit so that the tool can start on the outside of the stock instead of plunging right down the center of the part, right? So just a few changes. And again, this is something quickly that you can come in here and do. And when we go into our manufacturing side of things, we can see that the Rotary Toolpath is wanting to update. So I'm going to go ahead and actually make an edit to it first. And now what I'm going to do is I'm going to go into the Geometry tab, because again, what it's doing in this specific scenario is that it's picking up the setup model geometry. Right? So what we want to do is we want to overwrite that geometry using this model overwrite. Select this model surface. And what I'm going to do is I'm actually not going to include the setup model in this instance. Right, so we're not including the setup model. So I'm going to go ahead and say okay. Oops. And then set this to be stock OD, which was the default. And then see what that toolpath gives us. So again, not making too many changes, just making a change to the surface and then making a change to the actual setup model that we had originally used. So again, you don't want to go overboard with some of these changes. You just want to make just a few changes just to see what kind of toolpath that gives you. Right, so it looks like it's still loading here. Let me create another toolpath here just to see the difference in the settings that I'm going to use. So I'm going to use that same tool. The setup axis is going to be the x-axis. Once again, the model surface is going to be this one right here. Now this time what I want to do is I want to go ahead and make a selection for this edge, right? And just to see what that gives us. So I'm going to go ahead and press OK. Notice that there's angular limits here as well. So I'll show a model in just a second just to see what kind of options that gives us, right? So I'm going to go ahead and just run this toolpath. And you can see that it's still climbing up the wall a little bit, right? So it's not necessarily doing exactly what I'm expecting. So let's go ahead and edit that toolpath once again. And again, want to make sure that you don't include the setup model. I'm going to change this to be model front. And then for the back, for the offset, I'm gonna go ahead and turn on the model just to see what happens or how it looks like with the actual model turned on, right? So we'll go ahead and expand the bodies, hide this out, and then see if that gives us anything better. Right, and there it is. And you can kind of see what's happening. And again, this is just the settings that are included or right out of the box for that rotary toolpath. It's spiraling its way in. So a common question I get is, can you do the rotary toolpath in multiple step downs? Unfortunately, you can't as of right now. Really, there's a workaround though. If you just do multiple toolpaths with stock to leave, that theoretically gets you the same result. It's a hassle though, so again, I normally don't recommend that. I would probably try to think of a different way to machine that, or at least do a roughing path for that. Rotary toolpath is really just going to be a finishing strategy, right? But from here, again, if we're happy with the toolpath, what we can do is just start fine tuning it a little bit, right? Maybe you want to go ahead and bring the step over down a little, just a tad bit. 0.1. Geometry is going to be good still. I'm not going to make any changes there. And then there's a rotary style toolpath, right? So that's going to be the one that I'm happy with. This one, you can see that it's still picking up some noise here in the back towards the wall. So I'm not going to go with this one. So I'm just going to go ahead and delete that one. All right. So next step is just machining some of these flats. So again, for that, just use a 2D facing toolpath. I'm going to go ahead and select a face mill. And this is where you want to be careful, right? Because again, the way that this part is oriented, so it has the actual edge of the hex here pointing up. So in order to get a rotation on your machine, you have to enable tool orientation, right? That's a lot of people aren't really as familiar with the tool orientation. If you want to rotate your part on your machine, you have to enable tool orientation, right? So in this case, the Z-axis is going to be this face here. X-axis is going to be this one there. You also want to be careful because look at the stock contour. So it's going to try to machine this entire area. So might as well just change that right now. And being that I'm familiar with the toolpath, I know that it's always going to try to go in line with the X-axis. So what I want to do is just make a pass direction of 90 degrees. Maybe make a max step down of 150 thousandths, right? And then say okay to that. And there's the toolpath, right? So what I can do next is, again, we're trying to be as efficient as possible here. So just duplicate that toolpath. There was a couple settings changed in there. I just want to go ahead and quickly make that same toolpath, just a different tool orientation. So we'll say edit. We'll clear out the chain. We'll clear out this face. And we'll apply that to be on this face here. So again, I can actually pattern that if I wanted to, 6 times around, but you'll see why here in just a second, why I don't do that. All right, so we'll use that chain instead. All right, so there's the facing toolpath. Now what I want to do is probably start roughing out some of this material. All right, so I'll go into the 2D adaptive. Again, 2D adaptive, if you guys aren't familiar with it, it's just a high-speed roughing strategy. Very similar to vortex milling or hyper milling, I think is another name that they call it. It's just a torquedoidal type roughing strategy, right? So the way it works is it's just looking for an optimal load. So if it sees an area that is going to be a spike in the tool load, what it does is it defaults to that optimal load that you have set. So if you can see in this image, some of the tighter areas, obviously that would spike the tool load if you're using a traditional toolpath. Again, with 2D adaptive, it maintains that optimal load that you set for a specific tool. All right, so pretty good, a really good roughing strategy here. So we're gonna go with the 2D adaptive. For this one, we'll select the 3/8 inch roughing end mill. Again, best practice is just select the bottom of the contour, right, when you're roughing. And again, it gives you a preview, and you can see right off the bat, it doesn't really look correct. And you can see why, because the Z-axis again is not pointing in the correct direction. So for this one is changing the tool orientation, right? Again, same exact thing that we did with the facing strategy. So I'm gonna go with this orientation here. And now the passes tab, we're gonna have multiple depths. And this is actually something that I always recommend a lot of people get into the habit of doing. So just right click on the box and say edit expression, right? And start working with some of these expressions. Again, start customizing your toolpath, start making sure that you're really incorporating the I guess the best strategies that's going to give you the best surface finish, right? And the best end results at the end. So for something like this, I'm just going to use the tool length offset. And you can see what happens, right? So it actually gives you a preview of the different parameters that you can use. Again, if you guys are often using the tool length offset, it's just as easy as clicking enter. Maybe I want to use half of the tool length of the flute length, right? Or if you want to use flute length, you can do that, divide that by 2, and then it gives you the correct parameter there. So this is where you set your optimal load. Stock to leave, we're going to leave the axial stock to leave at 0, right? So we just want to leave a little bit of material on the roughing, on the walls of the part, and that should be good. So I'm going to go ahead and press OK there. Right? You can see that it's just giving us, so the optimal load, or the roughing step down that we set, it's actually going to be enough for this pocket. Now you want to be careful here, because again, the bottom height of this toolpath is going to be the bottom edge. For this, you might want to go slightly below that, right? So maybe 100 thousandths. And you can see kind of the updated result there. Again, I want to use that same strategy. It's only going to be a little bit different. Now it's going to be on this slot. So what are we going to do? Duplicate that toolpath. Select edit. This time we're probably going to change tools to a 1/4 inch flat. So we'll use this one. The chain for this is going to be on this face. So you want to select the tool orientation correctly. X-axis is going to be this. And say OK to that. Right, so again, we get the same exact toolpath, and now it's just updated, right? So it's updated to match the whatever pocket we selected. Again, you also want to be careful here, because it looks like the top height isn't set correctly. So you can just right click on this, say edit, and then modify the top height, right? So instead of a stock top, just set model top. Again, try to limit the selections. Obviously you can right click or click on this, say selection, and then select the top surface. But for something like that, just click on model top. And there's the updated toolpath, and then do the same thing for this toolpath here, right? So say model top. All right, so there's the positional toolpaths, right? So again, what you can do here is just pattern them if you wanted to. If you want to do a finishing strategy, you can. Again, a quickly way to go about that is just right clicking on this and using these derived operations. So really what derived operations, what it is it gives you the same exact settings that you set, granted that they're available for a specific toolpath. It uses the same tool, uses the same geometry, uses the same settings. It just gives you a different toolpath strategy. So for something like this, we're going to go with the 2D contour and really just say okay, right? We might need to change the depth, but that really shouldn't require too many modifications. And there's our 2D contour. So do the same thing for this 2D adaptive, right? Create derived operation, 2D milling. It's going to be again another 2D contour, and click OK. Right, so now what I can start doing is I can select the toolpaths that I want to pattern, and I can go ahead and go under setup and say new pattern, right? And it's really as easy as just creating a circular pattern. What's the axis? It's going to be this axis here, and then giving the instances here. Now you do want to be careful. So there is different operation orders that you can select. Again, there's a webinar that we did on that, but for this specific operation or this specific strategy, I'm just going to leave it as order by tool. And we'll see here what it does as we're simulating, right? So we'll go ahead and do a quick simulation of what we have so far. And then hit play, right? And there's our rotary toolpath. Again, it's spiraling as it's working its way into the part. So I'm not as concerned. There is actually a setting for this toolpath if you want to offset it. So right now it's actually in line with the x-axis. If you want to offset that so that you don't cut with the center of the tool, that is an option that you can enable inside of this toolpath. So just wanted to make you guys aware of that. Right, so there it goes. I'm going to go ahead and go to the next toolpath. There's a facing toolpath. Again, you see that it leaves a little bit of, it's leaving a little bit of stock there. So we'll see if there's a way to handle that. And this is what order by tool is doing, right? So again, if you guys recall, we machined out this pocket, we roughed it out, and then we did a finishing strategy, and then we went to this slot here, roughed it out, and then we did a finishing strategy. So order by tool keeps the pattern so that you're just using the same tool, and you're machining all instances that tool is going to be called out for. Right? So we're machining all of these pockets because all of these pockets are being machined with this tool. So it's doing all of those first, and then it's going to go ahead and transition over to the next tool. All right, so again, not to be fooled, the tool is not going to be the one that's moving when you machine this part. It's actually going to be rotating the part. So again, you do want to be cautious there. So even if it does show some sort of collision at the bottom, you can know that that's not really going to be the case here. And there's a finishing strategy for it. Right, so for something like that, I might want to reorient my 2D contours just so that I avoid any tool changes, right? So again, we're trying to be as efficient as possible here. Try to avoid the tool change and then carry those out here as you're going. So that was the so that's the pattern. Again, for the last couple steps here that I would probably do is just do a wrap toolpath. Again, that's going to be as easy as just selecting 2D, and I'm going to go ahead and collapse this. And what I like to do is I actually like to create new folders. So get in the habit of just creating new folders. Delete this. There we go. And we'll call these wrap T. And now what I can do is just start adding my toolpath. So again, it's going to be a roughing strategy. So it's going to be a 2D adaptive. It's going to be a wrap toolpath. Right? This enables it to wrap the pocket around a specific cylinder or a selected cylinder. So my wrap cylinder is going to be this face here. Pocket selection, it's going to be that pocket there. A common question I get is, does it matter which face you select for the cylinder? It does matter. If you select the outside surface, obviously it's going to give you a different diameter. So it is going to make a difference if you select a larger, bigger cylinder. So just be aware of that. It does give you different results. So for this one, really, I'm not going to make too much changes to this one. I'm going to go ahead and press OK, and then just see what that toolpath gives me. Okay, so looking pretty good. And now what I want to do is I want to go ahead and take a look at just one of the additional tools, right? So if I click on inspect, and this is a tool that not a lot of people are probably aware of or familiar with. There's a minimum radius analysis, right? So if I'm trying to see what's the minimum radius on this part, or the minimum tool that I can machine with, I can just grab this handle, select the body first, grab the handle, and you can start seeing that if I have a tool with a radius of 0.149, I can't machine the features that are in red. Right, so this is just a quick way for you to analyze the part and see what features I can machine with a given tool. Right, so you'll see that if I have a 1/4 inch tool, so it's going to be a 1/8 inch radius. there's going to be certain areas of this part that I cannot machine. And we talked about this. This is there's a reason why some of these edges are red and part of them are green. So there is a webinar where we explain this. So if you'd like to learn a little bit about that, again, feel free to look through our YouTube channel and take a look at that video. So again, for this one, just be aware that if I use a 1/4 inch tool to finish the feature here, it's not going to give me the correct result, right? But again, for this one, just for the webinar, I'm just gonna go ahead and go with the 1/4 inch tool there. One thing that I did notice is that I can probably machine out this other pocket and then pattern this around, right? So I'll just add that pocket real quick. Right click on this, use that same strategy we're using, 2D contour with the derived toolpath. It's a wrap toolpath, it automatically knows that. And there's gonna be our wrap finishing strategy, right? So similar to these, I'm gonna go ahead and just pattern this around. So create a new pattern. It's gonna be a circular pattern. And then the axis is already selected there. And I think it's 4. There it is. And then just rename this, right? So this is gonna be the hex flats, just to make sure that we're keeping track of things here. All right, so let's talk a little bit about the in-process stock verification. So the way that works is that, again, you have this little icon up here at the very top. It's currently turned off, so you can turn it on or off depending on what you like. It does sometimes, if you have a lot of toolpaths or if there's a lot of calculation, it can slow down your machine down a little bit. So just be aware of that. If maybe your laptop isn't up to spec, or maybe you haven't updated, or graphics card isn't working that well, you might want to be careful using this in-process stock verification. But anyways, the way that it works is you just select the toolpath. Again, it's going to be active up here. What a lot of people aren't realizing too is that there's a few options at the very bottom that are now available, right? So you can turn on the links or leads, the cutting moves. You can synchronize the view with your active setup, and you can synchronize the visibility with the active setup as well. So I'll show that in just a second. But you do have an option down here that you can also turn it on or off, right? So you can turn on the in-process stock. You can check that on. If you check it on, it starts sending that on. So what it does is it's really just simulating so it's showing you the stock simulation as if you would have simulated that toolpath, right? Or up to that point in that toolpath. So if we select this 2D contour in the pattern, notice that it machines out all of my contouring operations. Same thing for the adaptive. Same thing for the contour, right? So now if I work my way down, again, it still keeps those slots, right? So it's not showing me something different. It still keeps that in process stock verification. And then do the same thing for the pattern. All right, you can kind of see this is a good way to visualize that. Okay, maybe for this 2D adaptive, I don't need to leave any material, right? So just leave that at 0. And then again, it quickly shows the updated result, right? So there's our 2D contour here. Right, so just a quick way to really start seeing. So instead of having to simulate on and off, you can just quickly turn that on, and then you can see exactly what you need to machine, and then what has been machined already. So let me just make a quick change to this. Really, the last step is going to be for me just to make a change to this facing toolpath. A couple options. You can either use a 3D adaptive. 3D adaptive actually does a really nice job of facing your parts as well. It just gives you a more, I guess, just a more organic toolpath. But what a lot of people would do here is they would probably create a sketch and then just do an offset. If you take a look at the passes, there's a stock offset option. So just be aware of that option, right? It actually just does an offset. So if you can think of us selecting this contour and then just offsetting it 1/2 inch, it's exactly what it's going to be doing. So we'll set that one. There's the updated toolpath. I'll right click on this, say edit, and do the same thing to this stock offset, right? And just do 1/2 inch there. And there's my updated part. All right, so that would be it for this part. Again, that's what I did here. Normally, you would probably take care of that in a lathe, right? So you would turn this down on the lathe two sides. You would take care of the inside as well, bore it out, and then you would bring it into your milling machine and then start taking care of some of these features. But like I said, we're just assuming that we didn't have access, and sometimes that does happen. We use what we can. We use the tools that are available to us. So sometimes we don't always have access to, to the machines that would probably be best for some of these features. So that's going to be it for the demonstration purpose of the webinar. Like I said, if you guys have any questions, this is a great time to start asking away. If not, here's my email. You guys can always reach out to me. Like I said, I'm always happy to help. If you guys need to do a quick screen share on some of the issues that you guys are having, I'm always happy to jump on that. So I'm going to take a look at my Q&A. So it doesn't look like we have any questions. Like I said, guys, if there's ever any questions that you guys have, Autodesk related, Fusion related, again, don't hesitate to reach out. I do want to point out, next week I do have a webinar on some pretty big changes that are happening around Fusion. Power Mill is actually going to get a repackaging, so very similar to FeatureCam. If you want to go ahead and take a look at the Fusion 360 repackaging with Power Mill, I will be doing one next Wednesday, so be on the lookout for that. Okay, so looks like no more questions, guys. Again, thank you for tuning in. Have a great weekend, and we'll see you on the next one.